Okay, so Math 21B, Exam 3 review. Let's start with question 1. I'm just going to reread the question for those of you watching at home. So, the table below shows the age and favorite type of music of 668 randomly selected people. And it breaks it down in the table here. Use a 5% level of significance to test the claim that age and preferred music type are independent. Or they could have also asked, use the 5% level of significance to test the claim that there is a relationship between the two variables, age range and music type, okay? So different ways of going about it. So it's not asking for it, but let's practice. Of our 4 different types of testing we're doing for this exam, what type is this? Chi-square independence, good. Chi-square independence. Very good. Okay. And if, let's say that you're ever totally lost on where to start, you just don't even know what type of problem it is, feel free to take a peek at what type of questions are going to be asked of you, because that kind of gives you a hint as to what type of problem it is. Notice how there is a table in which it's asking you to fill in the expected frequencies. There's only 2 cases in which that occurs. Chi-square for independence or chi-square for homogeneity. Those are the only 2 in which you'll see a table that's only asking for the expected values. So that could at least help you narrow it down.
Thank you.
Okay? So, what are the null and alternative hypotheses? Well, for chi-square independence, recall, you just state what your 2 variables are. And for your null, you say they're what?
Dependent.
Independent. Independent is the null.
Oh.
And then for the alternative, you again just state your 2 variables and say that they're what? Dependent. Good. So, for the null hypothesis, state your 2 variables. I'm going to say music type. And you say age range, age group, however you want to phrase it, are independent. You also could have swapped the order. You could have said the age group first and then music type. Either way, just as long as you state the 2 of them and that they're independent. For the alternative, you restate your 2 variables. But this time for the alternative claim, we're claiming that these 2 variables are dependent. Part B. Using your calculator, fill in the expected frequencies in the table below. Are the criteria for the chi-square distribution met? Round to 3 decimal places. Okay, so to find our expected values, we know we need to enter the given data values into matrix A. So I'm going to go ahead and do so. Okay, so second matrix, go over to edit. So the first thing you want to do is adjust the number of rows by columns. How many rows does our table have? 3. How many columns? 3. It's 3 by 3. It doesn't even give us the totals column, which is fine. If it did give us the totals column, you do not include them, right? Do not include them. And then enter in the data, the given data. So I'm just copying this from the table that was given.
I have the 3 by 3 professor had 3 by 4, so I've been through the site. You said not to count that side.
Yeah, don't count the total column if there is a total column, but there's not here, so we're going to still count all 3, the rock, pop, and classical.
Yes.
Once you've entered in all of your data, you go over to Stat, Tests, and scroll down to the chi-square test. Oops, went too far. Chi-square test. Hit Enter. The observed is A, which makes sense. That's what was given. That's what we observe. The expected, the calculator will put the expected values into matrix B. Hit enter, and it gives us all of the following information, which we do need all of this, just not right this second. Question?
You're stopping at observe A, in or there, or are you going all the way down?
I'm going all the way down to calculate.
Okay, that's what I
Yep,
thought.
all the way down to calculate. So before I utilize this information on the calculator, I'm first going to look at matrix B because I want the expected values. So I go back to second matrix, edit, and B. Now, it looks weird on this app calculator. On your physical calculators, you should be able to see it better. But I'm just going to take the values given by my calculator in matrix B and enter them in for my expected values. So 64.766, 77.844, 65.389, 68.192, 81.961, 68.847. Again, these are coming from matrix B in the calculator. 75.042, 90.195, and 75.763. So now we're able to answer the question, which that is the criteria for the chi-square distribution met. Is it? Yes. Why?
They're greater than 5.
Yeah. Yes. Each expected value, which we just found, each expected value is greater than 5.
Okay, we're gonna look at it. Okay, cool.
Any questions so far?
This whole test is greater than 5, right?
Yes.
No
Yes.
10, no 30, no nothing.
Correct.
You're rounding as you go, I see. You're rounding it off as you go.
Mm-hmm.
9, 5.
Part C, find the test statistic, degrees of freedom, and p-value. Well, lucky for us, all of those are in the calculator. I'm just going to get out of this matrix. To do so, I'm going to do second quit. So second quit. And there's all the information I need right there. Okay? If you accidentally cleared this information out, just do your chi-square test again. Just do stat. I'll just do it. So let's pretend you're like, oops, I accidentally cleared it out. It's gone. What the heck do I do? Just repeat the steps you did. Just do stat, test, and go down like once again to chi-square test. Oops, right there.
Secret
And
school
there's-
hacks nobody knows about. It's called Nerd AI.
Ignore
You can
this.
literally ask it to do any
Ignore it.
assignment.
It's not letting me
So I
skip.
asked it to write
Are we able to just write all of that down first when it pops up?
Yeah, if you want to. If you wanted to, once this pops up on your screen, if you just want to jump to that part of the question and write it down real quick, you're more than welcome to. Yeah. So if you're like, oh, I found this, now let me go ahead and fill it in. It's not letting me move.
Mr. Moss, on
Mhm.
the calculator, I didn't see the last row. I got everything else. I did what you said, put it in B, calculate it down. Maybe I'm missing something. I mean, I wrote it down from Angie, but I.
So my recommendation, instead of viewing it like this,
Mhm.
do second matrix, go over to edit, and then go down to matrix B. And see how much prettier it is. So it's giving you the same info,
Yes.
but personally, I think in the edit view, it looks better than if you were to have it populate the other way.
You're right. Thank you so
Mhm.
much.
Okay, so let's just round the it didn't say where to round, so I'm just telling us where to round. The chi-square test statistic, let's round that to 3 decimal places. So again, I'm getting these 3 things from here. I'm just bringing it over. So that is 12.954. Degrees of freedom is 4. The p-value, let's also go to 3 decimal places, is 0.012.
Where am I? Wait. Oh, there.
So all from the calculator. Isn't that lovely how it's all just from the calculator?
Yes.
Calculator
One
is
more
your
time,
best
please.
friend. So we're looking for the chi-square test statistic, the degrees of freedom, and the p-value, all three of which came from here, from the calculator. And I just rounded to 3 decimal places.
Anthony, do you know how to get to that?
That's in second test?
No,
stat and test and then chi-square.
Okay, yeah, I remember that part in there.
Yeah, this is excellent time to practice with your calculators, guys. Make sure you're able to follow along on your calculators.
Oh, yeah.
No, go all the way down. You just keep hitting enter. There you go.
Okay. Thank you. Yes, wow.
Okay. And now we can start working on our conclusions. So first, it's just in general about the null and alternative. So our p-value, I'm going to convert that to percent, is 1.2%. Is that less than the significance level of 5%? Yes. So it is statistically significant, which tells us to reject the null and support the alternative.
I have a question.
Mhm.
So for me, I just put reject the null and support the alternative. Would that be what's taken off, or do I have to do it exactly like that?
Well, technically, this doesn't say explain. It doesn't say why. So technically, if you were just to write that, that would be okay. But if it said to explain, or if it did say why, the explain and the why part is this first line here.
Okay.
Okay.
So then we can state it in the context of the problem. Well, at the 5% significance level, the sample data support the claim that, and then you just restate what your claim was. And our claim, which is your alternative hypothesis, was that music type and age group are dependent.
Dependent. Seems alternative, right? Alternative.
Yes, dependent was our alternative hypothesis.
Conclusion is the same as alternative.
Yeah, I was looking at my phone.
I understand.
Yeah.
It's not related.
So that is it for the chi-squared for independence.
Thank you.
Any questions on any part of that problem?
Yes, Professor, like earlier in doing the calculations in the matrix, I didn't go through proper area there. I gotta really get.
Yeah, got like when it comes to the calculator, guys, you just gotta do it again and again and again and again until those steps are like ingrained into your brains. All right, next question. Number 2. A teacher figures that the final grades in the chemistry department proportions that are distributed as follows: 25% A's, 25% B's, 40% C's, 5% D's, and 5% F's. At the end of a randomly selected semester, the following number of grades are recorded for 160 students: 42 A's, 36 B's, 60 C's, 14 D's, and 8 F's. Test the claim that the grade distribution for the semester is different than what is expected. Test at a 1% significance level. All right, once again, I'm going to give you a 5-minute head start. I do not expect you to finish it in 5 minutes, but just see how far you can get.